Hi. I'm sure there's people out there, but all I can see are lights. So therefore, if you, we'll probably do some questions at the end, but if you have questions or comments, you'll just have to yell them out. So my name is Darin Briskman. I am with the Database Analytics, Machine Learning, and Blockchain Services team, which we have the honor of building and doing these services so that you can hopefully use them. And today, I'm going to walk through some of our thinking about how you can make better decisions. So what do we actually mean by that? Well, we sat down with our whiteboard about 10 years ago and thought about what is it that we believe that matters here. So the first piece, this is one of those things that seems really obvious, but people forget about it. The reason to do analytics, the only reason to do analytics, is to help people make better decisions. If you're doing analytic work that can't be used to make a better decision, you're wasting time and resource. And we've noticed that a lot of people spend a lot of time doing stuff that when you go back and say, how is this helping anyone make a better decision? It doesn't. The second piece there, all data has value. You don't know what the value of that data is sometimes, but somebody does. So how do we make this stuff cheap enough and scalable enough so that no data gets thrown away? So that all the data becomes available and usable. And then the third one is this shouldn't be a priesthood that with limited access. Everyone in the organization and outside the organization, citizens, stakeholders, other countries, should have access to that data, of course, subject to access rules. You know, we're going to keep private information private and so on. So this gets down to what we've traditionally seen and what we now think we need to move away from. Because traditionally, analytics consisted of putting some of the data into a data warehouse with some analytics on it. But those data warehouses were kind of expensive, so you ended up throwing away about 90% of the data. And the analytics tools that you use to create all the charts and graphs and forecasts were also really expensive, so only a small number of data professionals saw them. So what we ended up doing is not only spending a lot of money, but, well, you know, if the minister wants an answer on something, then they'll get that answer in a couple of hours. But the minister doesn't make all the decisions, right? It's that person 3 levels, 5 levels, 17 levels down who needs information to make decisions, and they don't get this stuff. If they're lucky, they get a spreadsheet that's 6 months out of date. That might show something that they can use. So what we're trying to do, and where we're seeing the real impact when this gets done, is go back through those rules and think about, one, how am I helping people make decisions? And I don't know what everyone's going to do, so how do I create capabilities for people to be able to use data to make decisions? Not projects, capabilities. Let the projects be the ownership of the people using it. And how do I make this stuff so that it's cheap enough and easy enough that everyone can use it, not just a small number of people? So when you take away all the marketing hype, that's a data lake. So I'm sure you've all heard the term. We're in Canada, there's a lot of lakes. In this case, what do we really mean by a data lake? Well, one, we mean it's big. It can grow to exabytes. Okay, you probably don't have exabytes right now, but you will. Secondly, that means that I can store and analyze all sorts of data. Relational data, non-relational data, you know, emails, structured charts, whatever. And it means I have purpose-built analytics tools that can actually use this, so that I have easy-to-use ways to make queries using standard languages like SQL, but be able to use it well. And I want it to be cheap. I'm not supposed to say cheap, but I'm not in marketing. Cost-effective is what the marketing people like to say. So actually, we just dropped that price. It's 2.3 cents a month or so per gigabyte. It's actually, I think, 2.1 now on the most expensive sort of S3. So if I use the very highest quality, highest data transfer version of that object store, it's $23 a month for a terabyte, $23,000 a month for a petabyte. But I have other options for things that are less frequently accessed that are as little as 1/50th that cost. So my petabyte cost can, my terabyte cost can drop from $23 all the way down to about 40 cents. So we can make that really cost effective. And I can query inexpensively or do full data warehousing inexpensively with managed services that can be turned on and turned off. So you're only paying for it as you use it. And give access to everyone. Now, good question. In your organization, and I'll bet everyone has pretty much the same answer for this, what is the most common analytics tool that is used by your people? Microsoft Excel. Okay, don't laugh, right? You're going to have to pull that out of the cold, dead hands of your analysts, right? They spent 5 years learning how to do pivot tables. You are not taking away their Excel. But we can hook Excel into the lake so that their Excel gets fresh and current information. And there's still a role for the high-end tools, right? The MicroStrategy, Cognos, Tableau, so on, for professional data analysts. What Amazon's also introduced is something in between called QuickSight. So QuickSight gives you a little more power than Excel, lets you do things like machine learning forecasts, predictions, anomaly detection. It's no harder to use than Excel, and it lets people publish dashboards that can be shared. And it's, again, designed to be cost effective. It costs 30 seconds to use for 30 minutes. The maximum per month is $5. So if you're somebody using this all day, it costs $5 a month. If you use it twice a month, it costs 60 cents. We want to make this cost effective to use throughout the organization. And that's kind of the key of putting these together. So everything else I'm going to say today is about how you actually do these things. So if you want to fall asleep now, feel free. So I was joking with our people that if we really wanted people to get a good nap, we should have served poutine instead of pad thai and done the full Canadian experience. But have you seen this before? A few people have. This is Jeff Bezos' handwriting from a United Airlines cocktail napkin from 1995. This was essentially the thinking that went into Amazon. And this is how we decide what to do whenever we enter a business or do a service. It's called the flywheel. So think about what this means. What's key is the customer experience. When you give a good customer experience, you get more traffic. Now, here we're talking e-commerce. If I get more traffic, I have more people who want to sell. If I get more sellers, I get more selection, which is a better customer experience. So I have a virtuous cycle there, which creates growth. And growth gives you a lower cost structure, which means you have lower prices, which is also a good customer experience. Because, as shoppers, I'm assuming most of you kind of like having more selection and lower costs, right? I do. I'm very cheap. This, by the way, was a white shirt that I spilled coffee on once. Couldn't get the coffee off. And my wife pointed out, new shirt, $50. Tie-dye, $5. Bet you can't see the coffee stain. So we think about this exactly the same way when we do data analytics at Amazon. It's not exactly the exact same terms, but it's the same concept. So I have a good customer experience for the people who are analyzing and using the data. That means they're going to share more, which means I'll have more people providing data and putting it into my lake, which means I have a more diverse data set, which is a better experience. And that makes my big data marketplace grow, which, of course, creates better operational efficiencies so I can do faster innovation. And this is the key to a successful data lake project. So there's a couple of things that are buried in here that aren't obvious, so I'll point them out. Customer experience, that's the people using the data. Make it easy and fun for them to pull and use and get the information they need. But the data provider experience is important too. Make it easy and simple for people to put data into the lake. Otherwise, you just get an empty lake. But if I can get all these pieces going together, I get something that grows. Like at the Canadian Pharmacists Association, where they've done a whole bunch of interesting things here. And one of the analytics apps that they're making available to everyone is mymedications.ca, where you as a patient or a loved one of a patient can easily do analytics on things that used to be really hard to get. Not just drug information, but drug interaction information and how those things come together and find them. But get consistent information about medications and get that to everyone, not just physicians. Right? Everyone who uses drugs or cares about someone who uses drugs, which is probably all of us in the room. I shouldn't say drugs, medications. Or personalized content, like our friends at Globe and Mail. So, make sure that they're not just feeding the news, but feeding the news that you care about. And the fun thing is, because this is all based on these standardized building blocks, they were able to do process store and analytics, building out a graph to understand customer or reader interests in about 60 days. And it increased engagement by about 25%. And what is engagement? It's the amount of time that people are spending on the Globe and Mail site, reading and looking at articles. We're successfully figuring out what people are interested in so that they read more. You're all doing a lot of work to get your information in public where citizens and others and residents and others can see it. You should also, I hope, care about that engagement. How do we make your stuff not just providing vital information, but making it interesting enough that they want to read more and learn more about your programs and how they can help? And have you heard of this company? It's a bookseller. As you can tell, I took this picture last week because it's talking about Mother's Day. If you forgot about that, go call your mother right now because you're in trouble. But we had an interesting problem. We originally built one of those traditional data warehouses back around 15 years ago. We built it out of Oracle. It grew up to about 5 petabytes of usable data, about 45 petabytes raw, and it couldn't grow anymore. And it was too hard to use. So we moved to a data lake. And moved it to a data lake that's using things like Redshift and EMR and the other Amazon tools. And we've moved from 600,000 analytics jobs a day to about 3 million in the last year and a half, while radically reducing the cost and increasing the usability. So let me dive into that a little bit. Everyone here has used Amazon.ca or Amazon.com at least once, right? Maybe? Okay. A vertical head motion indicates a yes response. A horizontal head motion indicates a no response. Most of you that I can see are doing this. That usually indicates that you're using certain herbs that are now legal for recreational use here in Canada, which is fine, but okay. So if you've used Amazon, you've probably realized we have a lot of different businesses, right? You know, just like, you know, there's a lot of different public sector groups. So some of those groups are really big, but even the big groups have huge differences, right? Amazon.ca retail versus, say, Amazon.in retail in India. You know, if I go to the Canada Amazon site and I look for phones, they're all going to be smartphones. If I go to the India Canada site and look for phones, about half of them will be flip phones, because that's what that market is looking for. So we've got a lot of those differences. And then we've got some huge you know, warehouses and whatever, and we have some small groups like Twitch. Anybody here ever hear of Twitch? It's a service of Amazon that lets you watch other people play video games. And I remember when this got started up, we actually acquired the core and built it out. And I thought, first of all, who wants to watch other people play video games? Well, I was wrong about that. There was, I think, a League of Legends championship recently that had something like 40 million live viewers. Okay, I don't get it, but that's fine. But the bigger question I had is, how do we make money showing other people play video games? And the answer turns out to be, you can comment on the players. So reading the comments is free, but writing a comment costs 1 cent. Could you believe we're getting hundreds of millions of dollars a year by charging people 1 cent at a time to trash talk video game players? But there's some analytics in there, and there's useful things to learn. All of these units are different size, right? Twitch is a fairly small unit, as opposed to, you know, the medium-sized units like Alexa, the giant-sized units like commercial. So we needed something that would scale with our ecosystem, just like you do. And we had 3 main goals. So that eye chart on the right is all the tools we were using in 2016. We'll distribute these slides. If you're not familiar with how this works, there's a survey you'll get at the end. If you fill out the survey, you get the slides. But only if you rate me above 4 stars. No, just kidding. Please give us honest feedback. So we had way too many tools. What we wanted was something that had SQL-based solution, because that's the language that people know to use for queries. We wanted to be able to use analytic approaches like machine learning and programmatic analysis. And I'll talk more about this in a bit. We wanted to both bring your own cluster and bring your own query. So we created a data lake, and we named it Andes, because the source of the Amazon is lakes in the Andes. Get it? The jokes are not going to get any better than this. Okay. But the idea of Andes, and by the way, if you're going to do a data analytics project, I found that there's a lot of technical keys to success that we've been talking about. One of the small keys, but it does seem that every successful project I've seen has a good name. And it's a name that relates to your organization, and it's not a name like Enterprise Database Source or something like that. It's not a name that sounds nerdy. It's something that relates to what your organization does. Anyway, Andes is the place for data at Amazon. Data producers put the public data in there. Data consumers use it. So if I tear that up into services, on the left side is how people get information into the data lake. OK, easy enough. So how do you make that easy? Well, one thing that we did is we looked around. We said, you know, about 90% or so of our data is in one of three repositories. It's either in DynamoDB, which is a scalable NoSQL database. It's in Postgres, which we use heavily for things that need geographic information, like shipping data. Or it's a stream that's coming from some sort of smart device or robots in the distribution centers. Or it's something else. So the goal here is to make it easy for producers. So if I am a producer and I have a DynamoDB database, I fill out a one-page web form. So I tell it the endpoint of the database, I provide some security credentials, and I give a few pieces of information that we can't automatically discover. Like, what's the email address of the data owner? Please give us a short description of the data set. Please give us a 50-character description of the data set, we call the micro description. So, the micro description might be, toy sales in Canada. And the longer description might be, a collection of sales divided by province and by date and so on. And also tell us what divisions it applies to. So in that case, it would be, the toy example would be retail, it would be toys, and so on. And then that's it. So the time to put a data set in, if you've got a Dynamo database, about 5 minutes. Same thing with Postgres. It's different underneath, but it's pretty much the same form. If it's a stream, give us the stream endpoints. Tell us what the stream is. And if it's something else, get your data into S3. So if you're using Neptune Graph, or you're using Oracle, or you're using MySQL, or one of the many other data technologies, or it's external data that's actually coming from outside of Amazon, like, say, census information or weather information, just get it into the S3 repository, and we'll take it from there. So we're able to make it very easy for people to put stuff in. Our goal is 99%. We're currently at about 97.5. So about 1 time out of 25, somebody tries to do this, it doesn't work, they have to call us for help, call IT for help. But we're getting there. That all goes into a raw S3 bucket. It then gets cooked using a tool of ours called Glue. So what does that mean to be from the raw bucket to the cooked bucket? It means that the data is put into a standardized, compressed columnar form. We use the Parquet format for that. So I have the raw bucket, which is really just there for heritage reasons, and then the cooked bucket. And then now I have the data available for people to use. So what does that mean to use? Well, the first thing you have to do if you're a data analyst is find your data set. So we set up a search engine. Does this look familiar to those of you who may have used Amazon in the past? Except it's data sets. And this is using a standard open source thing called Elasticsearch, and indeed deployed using Amazon Elasticsearch Service, which is the service to make it easy to deploy Elasticsearch. And so you might notice I have names of data sets and owners and data set sizes and reviews and ratings, because we asked data analysts to tell each other how good the data set is. I was at a meeting last December, and somebody walked in a little late, and everyone said, "Hey, it's Mr. Two-Star." I feel highly confident that he left that meeting to go clean up his data set afterwards, as well as the name of the owner. Why is the name of the owner and the email of the owner so important? Because let's say an analyst is trying to do something and there's a column and they don't understand what it means. I don't want them to call IT. IT doesn't know what that column means. IT would just go pass that on to the data owner. So get out of the loop and just go directly to the data owner and say, hey, what does this column mean? And if the data owner keeps getting the same question, maybe they'll relabel the column or do something to make it easier to understand. In any case, I've got these data sets. I've got down the left is what's called faceting, which is an automatic element of Elasticsearch. So I could drill in easily and say, I just want data that is about clickstream, or I just want data that is glance views, or something like that. And then the next screen, which I can't show you because I'd have to redact all the information, but it would, driving into one of these data sets is going to be, OK, here's the shape of the data. Here's how many columns. Here's, these columns are integers. These columns are floats. These columns are strings. How many rows are there? Here's some sample data. And then you can decide to use it. So how are you going to use it? Well, you got 3 choices. One choice is to directly query the data as it's sitting there. using a tool called Amazon Athena. That's a serverless query tool. It's actually based on Apache Presto under the hood, but all I have to do, it's already preset as a table. It's sitting as an S3 object, but it acts as a table, so I can just run a SQL query on it. My second choice is to say, give me a copy of that data, because I might want to enhance it or change it or combine it or do something with it. So it'll copy that into my S3 bucket. And once I've done that, I can use whatever tool I want. I can use EMR, the whole Apache Hadoop family of Hive and HBase and Spark. I can copy it into, my third choice is copied into a Redshift, a data warehouse. And if I don't have a data warehouse, click here, it'll set up a Redshift cluster for me. So I have all of these choices in order to do the analytics and do it easily. And what we often see happen is people like data scientists or data analysts will take that data set, enhance it or change it or make it more interesting, and then donate it back into Andes as a new data set. And then part of the notes is to show the heritage, to say this data set was built out of these other data sets. And that lets us find interesting things and correlations we didn't know. One of the data analysts was showing me a fascinating correlation between Lego sales and weather. So now we're trying to figure out if that's just a coincidence, like that 10-year period where hemlines and gold prices were correlated, or is this something that actually means something? But this becomes the kind of the interesting things that you can do, because having all this information available to everybody lowers the cost of curiosity. It means if I want to figure out what's happening here, I can figure it out. I can give it a try. I can do experiments. I can take advantage of the cloud. Here's one of the ways the cloud is so powerful here. Let's say I'm going to do a big regression analysis that might take 10 days to run on a server. Well, you probably know this. At Amazon, we charge by the hour. Actually, it's not true. We charge by the second. If you look at an Amazon bill and you use something for like a minute and 10 seconds, you'll be charged for 1 hour divided by whatever that is in a percentage. So running one server for 10 days, or running 10 servers for 1 day, or running 100 servers for 2.5 hours, or running 1,000 servers for 12 minutes, or running, say, 4,000 servers for 3 minutes costs exactly the same amount. So why wait 10 days when I can get it in 3 minutes? And this means that the things that used to be very frustrating, right? The analyst will set the job to run and go home and come in the next morning and hope it completed and just didn't get an error message. Now they can do 100 of those jobs in a day and actually start getting real depth into the information and answering the questions that we didn't know we could answer and finding that information. Or taking that information and putting it into machine learning and being able to do interesting predictive analytics or interesting correlations on it and submitting that back in once we learn things. I'll give another Lego example that these people found, and then it works back in our marketing. I found this kind of interesting. People who collect Legos will buy all sorts of Legos, including Batman Legos. People who like Batman stuff will buy Batman Legos and have no interest in other sorts of Legos. Don't try to sell the unicorn Lego to the Batman people. They're just not going to buy it. Can you see how this helps us make sure that our marketing is more relevant? I'm sure you can think of lots of other kind of correlations like that you can find around citizen behavior, adult behavior, and economic behavior that help you avoid wasting effort on things that'll just be wasted. And this really is where the data analytics becomes interesting. Not just finding fraud and abuse, does that well too, but finding new opportunities and things we didn't know were there. So, from a technical point of view, it's just microservices, a chain of microservices. And we built this out. So we have, if you look across the chain, you collect the data, that's the ingest. You store the data. Now, mostly that's about security. So as I put the data into the S3, how do I assign appropriate security on the data? Because as I said, it's accessible to everyone within rules. In that Amazon example I gave, I work for Amazon Web Services. So when I went to look up something on Legos, I didn't get the data. I got a form to fill out that said, you work in web services. Why do you need data on Legos? So I could fill out that form, and it got passed to that data owner. I said, well, I want to use this as an example, and I won't use any customer information. And they sent back, nope, there's no customer information in here, so you can use this one within the security parameters. Now I have permission. So you work all those rules in the store. Discover is that search engine I was showing. How do we make it easy for people to find what's out there? Subscribe is how you connect to the data that changes every day. So when I make a copy of that data into my own copy to play with, I can say, just give me one copy, or subscribe me to the daily changes or the hourly changes that come through. And then, of course, we have the services that actually deliver, and then the services do the analysis, tools like Redshift, EMR, and Athena. And it doesn't have to be Amazon tools. We have great partners like Cloudera and Tableau and others who do interesting things. But it's all a collection of services. Now, how to do this is pretty straightforward, but there's a lot of pieces and there's a lot of work. So we had customers say, well, why can't you just automate this? So we said, hey, that's a good idea. So we call that lake formation. So this is a service that is still technically in preview. You can sign up for a preview right now, which is what we call a public beta. And it will be generally available very soon. But this is about building out the kind of data lake I just talked about in an automated way. So that means it comes with these blueprints to connect to various sources. So as I said, in our world, those sources are Dynamo, Postgres, streams, and other. In your world, they might also, or instead, be Oracle or DB2 or mainframe DB2 or some agencies Informix or Microsoft SQL Server or whatever combination that makes sense. So we put together those sources with blueprints to make it easy to pull that data in and then crawl the data. This shows how bad we are at marketing, that we use large bugs to indicate how you want to deal with your data. It's supposed to be a crawler. And then that's how I get it from the raw into the cooked. And then in lake formation, it has simple security management to help me figure out how I do table level, row level, column level security. IAM is Identity and Access Manager. That's my security rules. KMS is my key management service. That's to manage the encryption keys, because everything should always be encrypted in today's world. So it's automatically encrypted in motion and at rest. That's how you manage the keys. We don't keep the master key. Only you have the master key. That way, if we're forced to hand over your data by some agency, it's encrypted. We don't want your data. We have enough trouble keeping up with our data. Your data is your business. And then finally, on the right, to have the kind of self-service and combined analytics. So the interface actually looks like this, where I just have some buttons to click to create a data flow or set up table permissions or search my data catalog or monitor the activity and see what's happening. So lake formation is a $0 service. It's free. Why would we do that? Well, the services underneath aren't free. What it's doing is it's kind of a set of wizards to configure other services like Glue and like CloudWatch to make it easy for you to set up this kind of a data lake. If you've been paying attention to Amazon services, we're doing a lot more of these. So for example, Control Tower is a set of wizards to do the same kind of thing with security. App Mesh is a $0 service to do the same kind of thing with microservice connections. So lake formation has helped you do that with data lakes. So to mention those services underneath briefly, Glue is both a data catalog and an ETL tool. So it writes ETL jobs in Python and executes them with PySpark. So it's a way to help move data and cleanse data and get it from one place to another. EMR is Hadoop. So this is 21 open source projects: Hadoop, Spark, HBase, Presto, Zeppelin, Livy. I can't rattle off all 21, it's a lot. What's important is that it's really easy to set up and go. If you've ever installed any of these things, it's like the scavenger hunt of your nightmares, where you're trying to pull all these open source things and get them to all work together. Here, you just pick which of the ones you want, hit up to 21 checkboxes, and hit go, and it sets it up for you. What I really like about this, though, is this is how we can get cost effective, because I can spin up the cluster in minutes, run my job, spin it down, and only spend money when I'm running the cluster. This makes it really easy and really cheap to do these really expensive analytics. So an example of that are our friends at BC Hydro. They need to do models of hydroelectric output on a dam with a lot of input that has to do with weather, water, temperature, other things, to figure out, what are the settings I want to put on my turbines to get the most out of the dam without, flooding any communities or breaking my voltage or whatever. So they used to run these things on local hardware. They had, servers at the dams. It took about 20 hours for a run, and they needed to do at least 10 runs a month. And it takes 20 hours for a run, and you all know how Murphy's Law works. It breaks in hour 19, right? and then you have to set it up and do it again. So we put this on the cloud. So what happens when I do the same models on the cloud? 10 minutes to spin up the cluster, an average of 12 minutes to run the model, 5 minutes to spin down the cluster, $10 per model. And then they figured out, hey, we can do this using AWS Spot. If you're not familiar with Spot, Spot is spot capacity. It's about 80% less expensive, but we can take it back with 2 minutes warning. So you run it on Spot, and if the Spot's not available, then you spend $10. If they run it on Spot, it costs them $2 to $3. So we just took what was costing a huge amount of money, and by the way, required like IT staff to support servers in dams, which is not a great environment to, it vibrates a lot and it's wet, so it's not the best possible place to put a server farm. And took staff that had to manage all that stuff remotely and turned this into something that is cheap, easy, and repeatable, and getting cheaper over time. And so because this is now so inexpensive, they can do what they couldn't afford to do before, which is say, okay, well, this is what that model predicts, but what if the weather forecast is wrong and this is the actual temperature? What would that change? So we can actually run multiple models here and really dive into how BC Hydro can do this as efficiently as possible. So again, this is the whole idea of having data, have it available to everybody who needs it, have it easily accessible. In this case, where's the data coming from? It's all streams or it's batches from public sources, and then be able to run it quickly and efficiently through systems that can be spun up and spun down so you only pay for what you're using. It's not like the old days where you buy a car and you hope you predicted what you need for the next 5 years. It's more like riding in a taxi. You only pay for when you're moving. Except, of course, you get to drive. The other service that you saw me talk about here is Amazon Elasticsearch service. Elasticsearch being a popular search engine. It's actually a REST engine on top of the Lucene Java library, which most search engines today are built on. Elasticsearch is easy to develop on, lots of standard templates, extremely widely used, and really difficult to manage. So customers came to us and said, could you make it easy to manage? So we said, okay. So the Elasticsearch service does not change Elasticsearch. It just provides a management tier. So it makes it a couple of clicks to set up the cluster, grow it, shrink it, spin it up, spin it down, whatever you want to do with it. And then we have that query tool I mentioned, Athena. So Athena is, instead of setting up the EMR cluster, just running the query. So why doesn't BC Hydro do this with Athena? Well, their query is a little more complex, and they need some stuff from Spark and some other pieces. But if I'm just doing a SQL query, I can do that directly with Athena. I don't have to load anything. I just treat the object on S3 as a table and do a select statement, or an insert statement, or an update statement. So we find this is a great way to do ad hoc queries or infrequent queries. If I'm going to be doing the same query over and over, I probably want Redshift, which is that data warehouse. And then the last thing I'll drill in a little bit is the visualization. So as we said, QuickSight is our tool to do visualization and simple machine learning placed at a level that everyone can use it. So you get dashboards that look like this. And they're interactive dashboards. I can drill down on them. I can pick any of those areas, or I can pick one of the graphs and drill down and get lower information, right? So this might be a graph at a Canada level, and I can drill down on it and get it at the provincial level. And I can drill down on that and get it at the municipal level, and kind of be able to see that information easily. And you can embed it in other things. So this is a fun one, the US National Football League. You know, football players today are actually data centers that weigh about 200 kilos and run into each other at high speed. So each football player has something like 15 to 30 sensors on them. And they're measuring like acceleration and speed and how hard they threw the ball and so on. Last year, the NFL decided that every team gets every other team's data. So every team went out and hired a bunch of data scientists. And then they used the QuickSight in order to distribute that data so everybody can use it. The embedded thing here is you point out they're not looking at QuickSight, they're looking at an NFL stats application. This is just embedded inside. So it's an easy thing to do programmatically. And so we get something like this.
34. Super Bowl 52. As time ran down in the first, Nick Foles was about to complete one of the most improbable plays of the game. With each tick of the clock, AI from Amazon Web Services processed thousands of data points to generate real-time insights, proving that a 19% chance was all Foles needed to change the course of history. Welcome to the next generation of football.
Okay, we're in public service. Our stuff is maybe less popular than sports, but a lot more important. But being able to put those kind of live predictions and live information is great. One of the things I love about this is in QuickSight, I can automate anomaly detection. I can have it do all the text that you see on there was automatically generated, and have it all by itself look at the chart and say, revenues across Canada were up 3%, but usually Quebec represents 16% of revenue, and this month it was 19%. And then start drilling down to see why these anomalies were there. Or forecasting. So here's my chart that shows something, whatever I care about, for 6 months. Just drag it out to the next 6 months, and there's my forecast. And it's an intelligent forecast that'll capture things like seasonality and trending and a good confidence band. So, and then here's an example of some of that plain language narrative. Currently, sorry, English only. I tried to convince my French translator to translate all that stuff in the French, and she said, no, that's too much work. But we will be doing the automatic generation as English. Now it'll add Spanish, French, and some other languages in the next month. So we're able to actually not just do the anomalies in pointing to you, but actually spell them out and be able to give you. So the things in green and red, I know it's a little hard to read, are just automatically, the green ones are saying this is above the target, the red ones are saying this is below the target. So it's easy to pull those things out in plain language, which also becomes really good feedstock when I'm wanting to do, say, machine learning, because then that becomes easy stuff for machine learning to use to do analytics and create machine learning models. So we have a lot of Canadians who we are very proud have chosen Amazon as their partner. We have stories about all of these. More importantly, they have stories about how they're using Amazon Web Services for some sort of analytics to help them do their mission better, right? And to get back down to the point I started with, to help people make better decisions, to help the operators at BC Hydro better manage the turbine settings and the electrical output of the dams, to help people at MPAC better make decisions about land management in the province of Ontario, to better help the people at ICAO better help airlines optimize international route operations and so on. And all of these are stories about what people can do to make better decisions and help make better decisions. So with that said, I decided to finish about 10 minutes early, so I have time for some questions. So let's see, I know somewhere out here is our lovely room host with a microphone. There you go. Y'all can turn the lights back up now. Or maybe you can't. Okay. So if you do have a question, what do we want them? We want them to raise their hand or just yell it out or what? I don't know. Or was my boring monotone enough to put you all to sleep and you're all just kind of waking up now? Okay. Questions? It's the shirt, yeah. As one of the people who works for me pointed out, if I get hit crossing the street, all the driver has to say is I was blinded by the shirt. And that would be no problem. Yes, sir.
Test 1, 2. Very nice shirt, by the way.
Thank you.
Can you please maybe elaborate on the blockchain services that you guys are offering?
So I just gave a whole hour in analytics, and you want to hear about blockchain? No. So I just got a question here. Okay, I'm not going to ask who's heard of blockchain, because you all have, right? How many people here think you have an actual use for blockchain? Okay, maybe it's the lights, but I see like 3 hands. So a few things about blockchain. One, all new services kind of get overhyped and then kind of drop off a bit and then come up into usefulness. Have you ever seen anything that got hyped so much and fell off so steeply? The last time in my career I remember a technology being so overhyped and so under-delivering was probably cold fusion, right? Which turned out to be measurement error and not actually a scientific breakthrough. But I believe we are right now going through the transition of blockchain being an overhyped technology into something that's actually useful for real work. So if you're not deeply familiar with what blockchain is, It's a immutable ledger technology, so it's keeping records that can't be changed, that are distributed among multiple locations so that you don't have to trust any given source. You only have to have at least, well, as it works out mathematically, at least 2/3 of the people involved have to be mostly honest most of the time. And then you can catch it. This is actually called the Byzantine general algorithm that's used, from where you have to assume that at least some of your generals are going to stab you in the back. But this gives us a way to distribute information in a trustable, usable way across a network so that I can do interesting things. For example, wanting to do microloans. We're working with the government of India in order to set up blockchains that go across multiple institutions to distribute the tranches for microlending, so that we have ways to be able to give out millions of small loans. And when I say small loans, I mean $100 or less. But in India, you can start a business on that and be able to distribute and manage these where it's not owned by any one organization. Because to be honest, the Indian government has found that they can't always even trust their own departments sometimes with money. But the departments don't trust each other either. So if we set up this distributed trust, they keep each other honest. I'm seeing it being used, interesting, in Peru to manage land titles. So what we found is that there are open source standards that create these systems. So I'm not talking about Bitcoin here. I'm talking about things like Hyperledger Fabric, which is an open source way to have distributed applications. What we're doing with Amazon Managed Blockchain is simply making it simple and easy to deploy those fabrics. So if you want to set up a Hyperledger Fabric, you create the fabric, go into the console. It's about 20 clicks. You have to pick a few things, like how big do you want it to be and how many members, and what will the voting rules be? Does the creator own it? Is it majority wins? Whatever. And then once you set that out, you just issue invitations. So you can invite anyone else who has an Amazon account, and if they accept that invitation, then they will be adding some servers into the fabric, and they pay for their resource. So it's very simple to set up this fabric and manage it, and so you can focus on the apps and running it. So in the first generation, we're doing Hyperledger. That's what is now live. We will soon be adding Ethereum, which is an alternate method which uses a cryptocurrency to manage the resources. Cryptocurrency also called Ethereum. But it's an interesting area. I don't think it's going to change the world, but I think it gives us another good option for data technologies that goes in that list of things like relational, key value, in-memory, graph, and now blockchain that serve specific needs. I hope that was reasonably clear. I don't have any slides for this presentation. But we're starting to see a world now where right tool for the right job. So things like key value databases, document databases, graph databases make more sense for a lot of jobs than the old table and column relational databases. So the key is picking the right technology for what you want to use. All right. Does anyone have an easier question? Yes, sir.
I got questions about the Amazon Elasticsearch. The service has been around for a while. And looking on the website, Open Distro Elasticsearch is coming out with the user authentication.
Yep.
Do you know when that'll be out?
So let me define a few terms here. So Elasticsearch, the open source Elasticsearch, has been around since 2009. Amazon launched the Amazon Elasticsearch service in 2015. So we're coming up on the 4th anniversary, and it's been a very fast-growing service, and we have a lot of customers using it. Although what I find amusing is only about 1/3 of our customers use it for search. More of our customers actually use it for log analytics, which is also a very good tool for. The problem that we had is Elasticsearch is open source. There's a company called Elastic.co that supports it and manages it, and Elastic.co stopped putting the innovations into the open source version. So what they've been doing, the way that they've decided to do their business model is to have non-open source software that extends Elasticsearch. And we had a lot of customers come to us and say, I don't like that. I'm using open source. I want it to be open source. So in collaboration with Expedia and JPMorgan Chase and about 50 other customers, we helped put together this idea of an Elasticsearch open distro. So it's a fully open source version of Elasticsearch that's adding some of the functionality that is not currently available in open source, like user authentication, like other security like encryption and so on. So the open distro the open distro is currently available. The user authentication is currently in there in beta, and I believe the plan for that is for it to be live either very late in May or very early in June. And we'll start seeing more and more innovation, we think, on Elasticsearch Open Distro. So again, the point, as we normally do at Amazon, is to find our customers tell us we want to run this open source thing, but run it easily, and we're providing infrastructure around it. So that's what's going on in Elasticsearch.
Hi, I think one of the
I can't see you. Where are you? Oh, there you are. Hi.
Too short. I think one of the major challenges I can see is that how do you actually build trust with your partners and clients and customers so that they share with you the current and relevant data that you're looking for?
Yeah, how do you get customers to give you data? Especially since they've been taught not to trust anyone, right? Because they gave all this data to places like Facebook and are not happy with how it got used. So part of that we find, a lot of that is transparency. One of the more interesting things that I've seen happen about making data open is some of the open data movements. City of Chicago, I never dreamed I'd say this in my lifetime, but the city of Chicago has become a leader in transparency with data. They have put the majority of their civic data online, and they just made it publicly available. And then people on their own made applications out of it. So one of my favorite applications that was just made by some guys in Chicago, or maybe girls, I don't know who it was, is called where'smysnowplow.com. And it lets the citizens of Chicago figure out where the snowplows are. And when they notice that a snowplow has been parked in front of Denny's for about 3 hours, they have a tendency to call up the Chicago Roads Authority and say, hey, where's my snowplow? Except they use more profanity because they're in Chicago, and that's the way it works there. But this has actually been a way to help citizens better understand what's happening in their city. And similar applications to do things with property taxes and sewage treatment and zoning issues. And actually getting citizens involved in zoning, which is, I used to serve on the city council in Portland. I could never get people to care about zoning unless it was their house that was being affected. But we all know this really, everyone wants to talk about the prime minister, but that local zoning commission affects your life a lot more than who's sitting in the prime minister's office. So these kind of things really matter for people. But I'm not really answering your question about how do we get the data. Part of that is thinking about what data do I really need to make a better decision, and then what proxies can I use for that data. So often data that we think we need from people, we can find a good proxy that can help us make a decision. Analytic data, this is one of those big keys, doesn't need to be precise, it needs to be accurate. Right? Precise means what's the difference between my revenue will be 1.81 billion and 1.82 billion? Who cares? You're not going to make a different decision based on that. Accurate is my revenue is going to be a little bit more than last year, or a lot more than last year, or a little bit less than last year. That's what you use to make a decision. I don't need exact information on every citizen to be able to make decisions. I need directional data that helps me understand what are changes in people's lives, not each person's life. Because the analytics that help you make decisions, unless you're actually doing social services or medical care, should not be focused on a person. They should be focused on groups and trends. And that's the kind of work that we can do and have been able to do effectively. So I will throw a couple of things that we can do to help you with this. Whether you know it or not, if you're an AWS customer, you have a solutions architect who supports you. If you don't know who that solutions architect is, ask your Amazon representative and they'll be happy to hook you up. One of the things that solution architect can do is help set you up what we call an immersion day, which is we come to you with a team and give you 1 or 2 or 3 days of hands-on education on how to use and manage these services, and maybe help you build out a prototype for what you might use. The other option that we give, that we offer to important customers, and the government entities in Canada certainly count there, is what we call a data lab. Data lab means you send 4 to 8 people to us for about a week. We lock you in a room with a whole bunch of Amazon engineers. Every couple of hours, we slide a pizza under the door. Developers are machines that turn pizza into code, right? So you gotta, provide the pizza. And it can't be deep dish pizza. It's got a Neapolitan to fit under the door. But in any case, feed them up and over a week build a prototype. So these are both programs that there's no charge for you. but it's, except of course for your time and attention, which we know is very expensive. But it's ways that we can help you do these things and accelerate, and we would be honored to help you do that. Please talk to your solution architect, and they can help you set those up. Did I almost answer your question there? Almost, okay. And I think I'm out of time.
Thank you so much, Darin.